In this video, we're going to look at another example of areas between curves. The question here is find the area of the region bounded between the curves y equals cosine x and y equals 1/2 and between x equals 0 and x equals pi. We will start by finding the intersection points of y equals cosine x and y equals 1/2. To find intersection point, we just make y equals y and solve for x. You can't always algebraically solve for x, but you can, in this case, we can reason it out from the special triangles, the 30, 60, 90 triangle. So what is the angle whose cosine is 1/2? Well, clearly from this triangle here, you can see that cosine of pi over 3 is 1/2. So x is equal to pi over 3. And the interval, of course, is x between pi and 0. All right, so now let's look at a sketch of the region. We have y equals cosine x, y equals cosine x, y equals 1/2, x equals 0, and x equals pi. So let's actually write down the definite integral that corresponds to the area under the curve. And we will formalize it in the next step. So the area is going to be, you can see to the left of the intersection point, which is pi over 3, cosine x is a top function. So we integrate from 0 to pi over 3, and the top function is cosine x. This is y top. And the bottom function is y equals 1/2. But between pi over 3 and pi is the reverse. Y equals 1/2 is a top function, and y equals cosine x is a bottom function. So we describe the integral differently. From pi over 3 to pi, the top function is 1/2 minus the bottom function is cosine x. And let me write this, y bottom here, and here 1/2 is a top function, y top, and cosine x is a bottom function, y bottom. All right, let's do that more formally. So we want to set up a definite integral to find area and solve. The points of intersection was found to be x equals pi over 3, y equals 1/2. On the interval x between pi and 0. You will notice that cosine x, the y value corresponding to cosine x, is bigger than 1/2 when x is between pi over 3 and 0. You can see this from the graph that cosine x is bigger than 1/2 when x is between 0 and pi over 3. And also, you will notice that 1/2 is bigger than cosine x when x is less than pi, larger than pi over 3. So the definite integral that represents the area under the curve is, let me clean this up, x is between pi over 3 and pi. So the definite integral is area is equal to integral from 0 to pi over 3 cosine x minus 1/2 dx plus integrate from pi over 3 to pi. The top function is 1/2, the bottom function is cosine x, integrated with respect to x. That's the definite integral. We're now going to solve that. All right, so what we have is integral from 0 to pi over 3 cosine x minus 1/2 dx plus integral from pi over 3 to pi 1/2 minus cosine x dx. This is a really easy integral to solve, so let's do that. What is the antiderivative of cosine x? That is sine x. What is the antiderivative of 1/2? That's going to be 1/2 x. Evaluated from 0 to pi over 3 plus, what is the antiderivative of 1/2? That's 1/2 x. What is the antiderivative of cosine x? That is sine x. Evaluated from pi over 3 to pi. Now apply fundamental theorem of calculus, and we get, put pi over 3 in, we get sine of pi over 3. Minus, plug pi over 3 for x, and we get 1/2 times pi over 3, that's pi over 6. Minus sine of 0, putting the lower limit in, minus 1/2 0 is just 0, plus, now put the upper limit in for the second integral, so we get pi over 2 minus sine pi minus pi over 6 minus sine of pi over 3. Okay, let's simplify this. So we have now, let's evaluate these things first. What is sine of pi over 3? Sine of pi over 3, that is root 3 over 2. Root 3 divided by, and that's from the 30, 60, 90 triangle that you should memorize. Sine of 0 is, of course, 0. Sine of any multiple of pi is 0. And sine of pi over 3, again, is root 3 over 2. So let's expand this and simplify. So what we have is root 3 over 2 minus pi over 6 plus pi over 2 minus pi over 6, distributing the minus sign, minus pi over 6, and minus times minus gives us a plus root 3 over 2. Okay, let's simplify this. Root 3 over 2 plus root 3 over 2, that's going to give us root 3 minus pi over 6, minus pi over 6, that's minus 2 pi over 6, that's minus pi over 3, plus pi over 2. If we decimalize this, we'll get approximately 2.26. This is the shaded area. Let's go back and illustrate it from the graph. There it is. So the shaded area is given by, the shaded area is given by 2.26, what we found for the definite integral. So the tricky part is drawing an accurate diagram. Of course, you have to know your special triangles, and you have to make sure that you describe the region differently in different intervals. Namely, from 0 to pi over 3, cosine x is the top function, and 1/2 is the bottom function. And that's why the first integral is cosine x minus 1/2 integrated with respect to x. The second region is from pi over 3 to pi, and now the top function is 1/2, the bottom function is cosine x, and then we basically add the two pieces, and we get the entire area. All right, thank you.